everyone, today I'm going to talk about byte and bit. Actually, the relationship is so simple that I can describe it in one sentence. 1 byte equals 8 bits. Yeah, so simple. Actually, they're the same size in computer memory, just not in the same units. Next, let's discuss in depth what is bit, what is byte, and how to distinguish them and convert them to each other. Okay, bit. What is bit? Bit is the smallest unit in the binary system. So what is binary? It means that each digit in binary system can only represent two values from 0. So here is 0 and 1. And in the decimal system is from 0 to 9, 10 values. So how do we represent the 2 in binary system? So I can show you. This is binary system and this is decimal. 0 is 0, 1 is 1, 2. And because there is no 2 in binary system, so I have to find a way to represent 2. Okay, we can consider the 2 as 1 plus 1. So the 1's place is full. We have to carry 1 to the 10th place. 10th place, okay, and set the 1st digit to 0. And then similarly, the 3 is 1, 1, 1. We can't call it 10 or 11. We just can call it 1, 0, or 1, 1. Okay, next, I want to talk about the relationship between bit and Bitcoin. And actually, we have been hearing a lot about the concept of Bitcoin in recent years. It was so popular. So, what does Bitcoin have to do with bit? The answer is they have nothing to do with each other. They just have the same name. Okay, let's take a look at what is byte. The term byte was coined to represent a group of bits used to encode a single character of text in a computer system. There are 3 key points here: group of bits, encode, and computer system. The first one, a group of bits. Let's recall that 1 byte equals 8 bits. So the group means 8. The second one, encode. Actually, the corresponding noun form of encode is encoding. Encoding is a very important concept in computer system. You can see this table. This is ASCII encoding. Actually, ASCII encoding is an old encoding. We can use it to represent all English characters and numbers. Speaking of which, I want to ask a question first. Why do we need to use encoding? Actually, encoding is a conversion from character to binary data. We can see here. The character is A, the corresponding binary is 0110 and 0001. Okay. And then why do we need this conversion? Because computer system can only process binary data. So, in addition to characters, any other information also have to be converted to binary. It is for the computer to process. Okay. In fact, the most common encoding we use now is UTF-8. What is UTF-8? UTF-8. So why don't we continue to use ASCII? Let's take a look. ASCII uses 1 byte to represent a character. 1 byte is equal to 8 bits. Okay, 8 bits. And each bit just presents 2 values. So we can calculate ASCII code can only represent 2 to the power of 8 equals 256 characters. Actually, for the English alphabet and numbers is enough, but it's not enough for characters of some other languages, Then in UTF-8, we can use up to 4 bytes to represent a character. So UTF-8 code can represent 2 to power of 32 equals 4,294 million and 967,296 characters. So it is very enough to cover the characters of in all languages of the world. Then next, the third byte point. Okay, let's clear the notes. Computer system. Byte is designed for computer system. So we can use byte in any different programming languages. In C and C++, we use unsigned char. In Python, we can use bytes. In Java, we can use java.long.byte. Let's take a look at how to distinguish them and convert them to each other. This graph shows the result of internet speed test. We can see that the internet rate is 123.04 Mbps. Please note that the B here is a lowercase b, small b. What's more, this is just an abbreviation. Actually, it is 123.04 MBs per second. From this image below, we can learn that the file size is 1.87 MB. Please note here the B is big B, uppercase B. So we can summarize the way to distinguish them. Bit is usually represented by lowercase b, while byte is represented by uppercase B. Now let's take a look at what are MB and KB in computer system and their relationship. We can see that first the MB is megabytes. Here, MB is megabytes and KB is kilobytes. Okay, we can see that 1 kilobyte equals 1024 bytes. 1 megabyte equals 1024 kilobits. So the conversion factor is 1024, which is different from the factors we use in our daily lives. For example, 1 kilogram equals 1000 grams. 1 liter is equal to 1000 milliliter. So they are 1000, not 1024. So the factor 1024 is only used for computer system. In addition, if we convert them to bits, okay, here we should multiply by 8. Let's review again. 1 byte equals 8 bits. So our actual network download speed should be the test rate divided by 8. In this example, our actual file download, let's see, here should be divided by 8 is 15.38 megabyte per second. If a telecom operator says your current fiber bandwidth is 200 Mbps, oh, it is so fast, it's 200. Actually, then we can calculate that the actual download speed is 200 divided by 8 is 25 megabits per second. Okay. So at this point, we should totally get how byte and bit are related. 1 byte is equal to 8 bits. Okay. Next, I will show how a computer stores a character in memory by debugging as a program. So keep watching if you are interested. Okay, let me show the code example. Here, actually, I wrote a program, C++ program. Okay. Yeah, I just declare an unsigned char named byte and put the value small u to it. Okay, you can see I use GDB to GDB. I use GDB to debug this tiny program. GDB out. Okay, let's set breakpoint at main function. Break and run. Okay, let's execute line 6. Okay, we can see, so we can check the form of small u in memory. Let's say the form, okay. X1, just show 1 byte, and T in the binary format. B is 1 byte. Okay, let's get the address of the variable byte. So we can see the small u existed in the form of binary is 0310101. We can verify the result at the ask table here. Small u and the corresponding binary form is okay. 1110101. So yes. So let's rehash. The computer system can only process binary data. Okay, that's all for today's video. Thank you. See you.